In mathematics, an interval exchange transformation is a kind of dynamical system that generalizes circle rotation. The phase space consists of the unit interval, and the transformation acts by cutting the interval into several subintervals, and then permuting these subintervals. Formal definition. Let and let be a permutation on. Consider a vector of positive real numbers, satisfying define a map called the interval exchange transformation associated to the pair as follows. For let enpha, define if lies in the subinterval, thus acts on each subinterval of the form by a translation, and it rearranges these subintervals so that the subinterval at position is moved to position. Properties. Any interval exchange transformation is a bijection of to itself preserves the Lebesgue game measure. It is continuous except at a finite number of points. The inverse of the interval exchange transformation is again an interval exchange transformation. In fact, it is the transformation where for all, if and if we join up to the ends of the interval to make a circle, then is just a circle rotation. The Weyl equidistribution theorem then asserts that if the length is irrational, then is uniquely ergodic. Roughly speaking, this means that the orbits of points are uniformly evenly distributed. On the other hand, if is rational, then each point of the interval is periodic, and the period is the denominator of if, and provided satisfies certain non-degeneracy conditions, a deep theorem which was a conjecture of M. Keen and due independently to William A. Veitch and to Howard Masser asserts that for almost all choices of in the unit simplex the interval exchange transformation is again uniquely ergodic. However, for there also exist choices of so that is ergodic but not uniquely ergodic. Even in these cases, the number of ergodic invariant measures of is finite, and is at most. Generalizations. 2 and higher dimensional generalizations include polygon exchanges, polyhedral exchanges and piecewise isometries.